When you create a table in your database, you define what's called the data type for each of the columns. And the data type limits what kind of data can be put in that column. It's essentially like a constraint. So if you define a column, for example, to hold dates, if you give that column the date data type, then if you try to insert an invalid date into that table, say you wanted to insert the date the 31st of February, you'd get an error because the 31st of February is an invalid date. If you try to insert some random text into a column that you've defined to have a number data type, you'll also get an error. So data types give you an additional layer of validation on the kind of data that's going into your tables. Different operations are also possible with different data types, and you might have even tried at some point to call the sum function to perform a sum aggregation over some column that held text. It wouldn't have worked if you tried that, and that's because sum expects to receive a number. Sum is a function that only operates on numbers. It doesn't know what to do if you give it a column that only holds text. Likewise, there are certain operators that will only work on different kinds of data types. So you might have noticed you can use plus, minus, multiplication, division on numerical data types. But if you tried to use the plus operator to add two strings together, that wouldn't have worked either. If you want to concatenate two strings together in Postgres, you use that double pipe symbol. I've listed out here the main ANSI SQL data types, and you can broadly sort of group them into a couple of different categories. So starting off, we have the character data types, character, character varying, and so on, and you can broadly classify those as being the character or string or text data types. Those are the types for working with text. Next, you have what are called the binary data types. Binary data types are great for storing some sort of binary format. Maybe, for example, you want to store some image data in your database. You could use a binary data type for that. Next up are the number data types. There's quite a few different ones: numeric, decimal, small int, integer, big int, float, real, and double precision. So these are the data types that you use for storing numbers. And you can even further subdivide that into a few different kinds of categories. So first up, you've got numeric or decimal. Numeric and decimal are actually the same thing. You can use either of the two. And what numeric and decimal do is store fixed or exact decimal types. So if you've got a decimal type, something with decimal digits, it's got a fractional component to it, you can use numeric or decimal to store that. And later on in the video, I'll go into more detail on when and where it's appropriate. Next, you have the types that are for storing integers. So that's small int, integer, and big int. And so these types are for storing whole numbers. And finally, we've got float, real, and double precision, which are the inexact decimal types. And you can use these for storing, again, decimal digits, similar to numeric and decimal, but the way that they store those numbers internally is different, and that has implications for both performance and accuracy of these types. Next, we have the Boolean data type, and the Boolean data type is pretty simple. It can just store true, false, or null. Remember that when we're working with SQL, we're dealing with three-valued logic, so it's not just true or false. And then finally, there's the date and time data types. Date, time, timestamp, and interval. And fairly self-explanatory, these are the types for storing dates, times, and intervals or durations between two times. What I've just shown you now is the ANSI data types. But data types is actually one of the areas where you'll find that there's the greatest amount of variation between different databases. And different database vendors have varied from the ANSI data types, sometimes quite substantially. You'll generally find the same broad categories of data types, so practically every kind of database has character types. Every database has binary types. It's extremely common that you'll find numeric and decimal implemented across basically every kind of database. All of them will have integers, they'll all have floating point types. Some databases will have a Boolean data type, some don't. And then practically all of them have ways of dealing with dates and times. But the actual names of those types and the way they behave can be quite different from database to database. So the coming few videos are going to be a little bit more specific to Postgres, where I'm talking about the behavior and characteristics of Postgres data types. Again, the same general principles will apply if you're working with a different database. So if you're using Microsoft SQL Server or MySQL, you can count on the same general kind of data types being available. It's just what you'll have to do though is look up the documentation to find the exact name of that data type and the exact way it behaves on that particular database. If you're interested in seeing what are the full list of the Postgres data types, there's some documentation available for that. So if you go to the documentation page and search for data types, this will be your first result. And you can scroll down the list and you can see there's actually a ton of different data types that are available, far more than the ANSI standard specified. And again, that's very common as well. So MySQL and Microsoft SQL Server have also implemented a variety of different data types, even more than the standard specifies. You might first be wondering, why are there so many variations of these different data types? So why is there a small int, an integer, and a big int, when all of these types are just used for storing integers? In the case of the integers, it comes down to a trade-off in space. Small int, integer, and big int each require a different amount of storage space. A small int takes up 2 bytes of storage, integer takes up 4 bytes, and big int takes 8. And what that means is that the values that they can store have different limits as well. So a small int can store up to about plus or minus 32,000. If you tried to insert the number 35,000 into a column that was defined as a small int, it would fail. You'd get an error. The integer type can handle numbers up to plus or minus 2 billion or thereabouts. And big int is much, much larger. So when you're creating a table and when you're defining the data types for the columns in those tables, you essentially have the opportunity to make a choice. If you know that the numbers that you're going to be inserting into that column are always going to be less than, for example, 32,000, you probably want to use a small int. You'll save storage space. Your database won't grow as big. Now, it might not seem like the difference between 2 bytes, 4 bytes, or 8 bytes is much, but you have to remember that's per row and that's just for one column. If you have a table with millions and millions of rows, and you have many tables with millions and millions of rows, that difference between choosing a 2-byte data type or a 4-byte data type can add up. Sometimes the difference between the data types is a little bit less clear. I mentioned that numeric and decimal versus float, real, or double precision is about precision or exactness. Numeric and decimal are fixed decimal types, whereas float, real, and double have variable precision. And what it comes down to is about the way that they store that decimal information. Float, real, and double precision generally take up less storage space, and they're typically a lot faster as well with computations. So adding a bunch of floating point numbers together or multiplying them is going to be a lot faster from a performance perspective than doing the same operation with numerics. But the trade-off is that there's error that's introduced when you're working with these variable precision types. I'll explain this a little bit more in a coming video. Jumping back to that full list of data types as well, you'll notice that there's this enormous list of types. So you've got types that are for storing JSON text. We've got types that seem to be storing geometric information like circle, path, polygon. There's types that store XML data. Each of these different types gives you something. They'll give you some sort of validation. So for example, if you try to insert an IP address that's invalid into one of those IP data types, you'll get an error. And so that's why it can be useful. You got some really helpful validation out of the box for free. Often as well, certain functions will only operate on particular data types. So there are functions that exist that will only work on points and lines, and so the data type is useful in that respect. For the upcoming videos though, I'm going to be focusing on the 3 most common kind of data types that you come across. Character data types, numerical data types, and date and time data types. They're the most common that you find yourself working with on a day-to-day basis. Just to make things a little bit concrete, let's have a look at the entity relationship diagram in dbeaver, and let's check out some of the data types that we're working with in our sample database. So you can see when you look at the ERD, it's already specifying the data types next to the different column names. If it's not showing for you, what you can do is right-click, go View Styles, and make sure Show Data Types is ticked. And let's look at the customer table. Store ID is int2. Int2 is actually just an alias for small int, and that 2 is referring to the fact that its storage requirements are 2 bytes. First name, last name, and email are what are called varchars. Sometimes you'll hear people pronounce that as varchar, and again I'll talk a little bit about the text types in the following video, and we can see all the different data types as well. If you want, what you can do as well is double click on that customer table, and then make sure you go down and you pick DDL from the side tab here, and you can look at the actual create table statement that created that table, and you can see how the data type was specified as part of that create statement. So we've gone create table public.customer, and you can see that there's customer ID that got the data type serial. Store ID got the data type int2. First name, varchar, and so on. And so this is how data types are specified in your create table statements. If you wanted to, you could jump over to a text editor right now, and you could create your own tables in exactly the same way like this. Create table, table name, and then specify a list of column names and their data type. Sometimes as well, you'll come across data types that are actually user defined. So if we scroll down and we have a look at this film table, let's double click on the film table. Let's have a look at this create statement. And there's this rating column that we've already used quite a lot of times, and you'll notice that the type is specified as MPAA underscore rating. Now that's quite interesting, isn't it? Why would Postgres have a data type specifically just for MPAA ratings for films? And the answer is it doesn't. That's a data type that we defined. And if you want to understand that type a little bit more and what it's actually giving us, what you can do is come up here to this sidebar. Let's go to the database navigator. Let's look at our Video Easy database. Let's go schemas, public, data types. And there's the MPAA rating data type. Let's double click on that. And we'll click source. And you can see that the MPAA rating is actually what's called an enum, or an enumeration. And what that means is that the MPAA rating is allowed to be G, PG, PG-13, R, or NC-17. It must be one of these values, and if you tried to insert any other kind of value into that column, you'd get an error. So it's essentially just another kind of constraint. Yet in this case, we defined our own type, and we got to say when we define that type, what values are allowed in that column. Spend some time coming up looking over these different Postgres data types. The idea isn't that you memorize them. The idea is simply just to be broadly familiar with the different kinds of data types that are available and that you could use in the future that might give you some benefit. They might save you from implementing your own validation rules. They might give you some performance benefits. They might give you access to a whole range of powerful functions that make what you're trying to do easier. But for the coming videos, as I mentioned, I'm going to take you through the character data types, the number data types, and the date and time data types. And we'll get comfortable with working with those. They're the most common that you run into on a day-to-day basis.